Hi, my name is Shahroz Ahmed, and in this video we'll discuss the basics about electricity. So in electricity we have to discuss the three main important terms. Number one is current, next one is the potential difference, and the third one is resistance. Alright, so let's start off with the current. So by definition we can say that current is the rate of flow of charge. The rate of flow of charge is current. So we can say that current is equal to charge divided by time. The symbol by which we represent the current is I. So I is equals to Q over T, where Q is the charge and T is the time, I is the current. The unit of the current is ampere, and we represent it with capital A. Now let's discuss about the direction of the current. So as far as the direction of the current is concerned, the current flows from the positive terminal of the battery to the negative terminal of the battery. Positive to negative terminal. So if we have a circuit in which we have a battery, we have a resistor. So over here we have the positive terminal, this is the negative terminal, so the direction of the current will be from the positive terminal of the battery to the negative terminal of the battery. The next thing that we have to discuss is the measurement of current. So how do we measure current? We measure the current by an instrument that is called ammeter. So ammeter is basically the instrument by which we measure the amount of current that passes through a circuit. So if we have a circuit in which there's a battery, there's a light bulb like this, and the current is flowing from the positive terminal of the battery to the negative terminal of the battery, and we want to measure the current through this circuit. So what we do is we will put an ammeter over here. The symbol for the ammeter is this circle with a capital A. So what will happen, the ammeter will measure the amount of current that will be passing through this circuit. Now the next thing that we have to discuss about current is the behavior of the current. So as far as the behavior of current is concerned, we have to discuss the current in series and parallel circuits. Series and parallel circuit. So what I'll do is I'll draw two circuits over here. One will be a series circuit, one will be a parallel circuit. So let me show you a series circuit. So series circuit is a simple circuit where two resistors are attached in this orientation. So we have a positive terminal of the battery over here, negative terminal over here. The current is flowing from the positive terminal of the battery to the negative terminal of the battery. Let's suppose this resistor is of 10 ohm, this resistor is of 5 ohm, and the total current that is flowing through the battery is 10 amperes. So what happens is 10 ampere will pass through this first resistor, and 10 ampere of current will pass through the other resistor. So no matter what is the resistance of the resistor that are attached in series, the amount of current will remain the same. Now this is for the series circuit. Now let me draw a parallel circuit. So in a parallel circuit we have two resistors that are attached in the parallel. This is the positive terminal of the battery, here is the negative terminal of the battery. Let's suppose this resistor is of 10 ohm, this resistor is of 5 ohm, and total of 10 ampere of current that is being produced by the battery. So what happens is when the current comes at this point right over here, some of the current will go through the 10 ohm resistor and the remaining current will go through the 5 ohm resistor. So if 3 ampere of current goes through the 10 ohm resistor, then 7 ampere of current will pass through the 5 ohm resistor. So we can say that the current splits in parallel circuits and the current remains same in series circuit. So conclusively I can write here current remains same in a series circuit and current splits in a parallel circuit. So this is basically the basics of current. Now in the next one we'll move on to the potential difference. Alright, so now we'll discuss the next term, that is potential difference. So by definition, if you write potential difference, by definition it is basically the work done per unit charge between 2 points in a circuit is called potential difference. Now we can write potential difference as, we can also call potential difference as voltage. So I can write it over here. It is also known as voltage. So we can use voltage in place of potential difference or potential difference in place of voltage. Alright, so I can write it here that voltage is basically equal to work done per unit charge, or in simple form it is represented with capital V, and capital V is equal to W over Q, where W will be the work done and Q will be the charge, and V is basically the voltage or potential difference. I can write it as PT. Now let's talk about the unit. So the unit of potential difference is volt, and we present it with capital V. Okay, now the next thing that we have to discuss in potential difference is the behavior of potential difference in a series circuit and in a parallel circuit. But before that we will see the instrument by which we can measure the potential difference. So how can we measure potential difference? We can measure the potential difference by an instrument called voltmeter. The symbol for this instrument is like this, a circle with a V in it. So let's suppose we have a circuit where we have a battery, and the battery is attached with a resistor. The current is flowing through the battery from the positive terminal of the battery to the negative terminal. Now if we want to measure the potential difference that is being dropped across this resistor, then we will attach this voltmeter in parallel to this resistor. So this is the parallel arrangement of the voltage of the voltmeter with this resistor. So in this way our voltmeter can measure the voltage in a circuit. Now the next thing that we have to discuss is the behavior of the potential difference in a series circuit and in a parallel circuit. Alright, so the behavior of the potential difference in a series circuit is that the voltage or potential difference splits in a series circuit, and voltage or potential difference remains same in a parallel circuit. So if we have a series circuit, whereas this is the battery, and that is attached with two resistors attached in series. This is resistor 1 and this is resistor 2. This is the battery. Let's suppose the battery is producing 12 volts and 7 volts are being dropped across this resistor. Then the remaining 5 volts will be dropped across this resistor. So this is how the voltage is split between the resistors in a series. Now let's draw a parallel circuit. So we have a battery that is of 12 volts that is attached with two resistors of whatever resistance, it doesn't matter. So in this circuit, this battery is producing 12 volts. Now whatever is the resistance of these two resistors, they both have 12 volts drop across their terminals. So 12 volts will be dropped across each resistor. So this is how we can say that potential difference remains same in parallel, but potential difference or voltage splits in a series circuit. So this is what we have for the potential difference. This is basically the basics of the potential difference. Now we'll discuss about the resistance. Alright, so now we'll discuss about the resistance. So resistance is basically the ratio of potential difference to current. The ratio of potential difference to current is resistance. So in simple words, or in simple formula, we can write resistance is equal to potential difference divided by current. You can also say the voltage, I'm just writing it as the potential difference. So potential difference to current is basically the resistance. So we can say that R equals to V over I is resistance. So R is representing the resistance, V is the potential difference, and I is being represented by current. So now let's talk about the unit. So the unit of resistance is ohm, and we represent ohm by this symbol. Okay, so this is basically the basics of resistance. Now we will discuss the different types of resistors. So the types of resistors. Number one, a simple resistor. A simple resistor is the one that we normally use in our circuits, that is used to control the flow of current. The symbol for the simple resistor is like this. It's just like a box type of symbol, and these two lines are representing the wires. Now the next one is the light dependent resistor. Light dependent resistor. So light dependent resistor is the one whose resistance increases with a decrease in light, with a decrease in the intensity of light. So when we put more light on the resistor, its resistance decreases, and when we put the resistor in more light, its resistance decreases, and when the light is lesser on the resistor, then the resistance will increase. So the symbol for the light dependent resistor is like this. So this is the symbol for the light dependent resistor, and whose resistance decreases as the light increases, and whose resistance increases as the light decreases. The next one that we have is thermistor. So thermistor is basically, it's a temperature controlled resistor. When the temperature of the resistor increases, its resistance decreases. When the temperature of the resistor decreases, then its resistance increases. So in this resistor, it is a light. It can be used as a heat sensor, and LDR or the light dependent resistor can be used as the light sensor. So the symbol for the thermistor is like this, a box with this type of symbol. So this is the symbol for the thermistor. And for the light dependent resistor, we can also call it as LDR. So these are the three main types of resistors that we mostly use in our circuits. So this is it for this short topic on the basics of electricity. So now one thing is left, and that is the relationship between the voltage, resistance and current. So let me just write it down here. So the relationship between the voltage, current and resistance is explained by a law, and we call that law as Ohm's law. Ohm's law says that the current going through a resistor is directly proportional to the voltage. If you increase the voltage, the current will increase. If you decrease the voltage, the current will decrease. However, the resistance of the resistor should remain constant. So I will become equal to V over R. So if we have more resistance, we will have less current flowing through that particular resistor. If we have less resistance, more current will pass through that particular resistor. So the relationship between the voltage, current and resistance is defined by the Ohm's law, and it is V equals to IR. So this V is the voltage, this I is the current, and this R is the resistance. So this is it for this topic of electricity. Now we'll try a question from the past paper of IGCSE Physics. Alright, so here we have an exam related question for the topic of electricity for IGCSE or GCSE Physics. So the question reads as: the diagram in figure 3 below shows a sensing circuit which is used to control a set of automatic lights. So we have a circuit that has been shown on the figure, and in part A it asks us about that what quantity is measured by the voltmeter. So as we have discussed that the voltmeter measures the voltage, so we'll just write voltage. So voltage is being measured by the voltmeter. Now the next question says add an ammeter to the circuit which could measure the current through LDR. So this is the LDR, you see, this is the symbol for the LDR. So this is the LDR, and we have to attach an ammeter so we could measure the current through the LDR. So let me just zoom it in. Alright, so we have to attach an ammeter that could help us measure the current. So this is the LDR, as we have discussed that we attach ammeter in series. So what I'll do is I'll attach the ammeter over here and with capital A, because capital A is the symbol for the ammeter. So I'll attach the ammeter over here. So this ammeter will measure the current that will be passing through this LDR. So this part is done. Now let me just zoom it out. Okay, now in part C. In part C it says when the potential difference across the LDR is 6.4 volts, the current in the circuit is 4.8 milliamperes. Calculate the resistance of the LDR. Okay, so for this question we have to use the Ohm's law. Now it says that voltage across the LDR is 6.4 volts. So the voltage from here to here is 6.4 volts. So as we have discussed that the voltage splits in series. Now as we can see that this LDR, that is a type of resistor, and this simple resistor, they are attached in series, and the total voltage is 12 volt. So the voltage has to split between these two resistors. So if 6.4 volts drop is across the LDR, then the remaining voltage will be across this simple resistor. So the voltage across this simple resistor will be 12 minus 6.4 volts. That would be equal to 5.6 volts. So the voltage across this simple resistor is 5.6 volts. Now what we have to do is we will measure. Now we have been given the current that is being flown through this LDR, and we have to find out the resistance of the LDR. So the equation is the question is quite simple, as it has been said that a current of 4.8 milliampere is passing through the circuit. So as these two resistors are attached in series, so 4.8 milliampere of current will pass through each resistor. So we will use the Ohm's law and find out the resistance of the LDR. So the voltage across the LDR is 6.4 volts. The current that is being passed through the LDR is 4.8 milliamperes, and we can convert that into amperes by writing it as 4.8 times 10 to the power of negative 3 amperes, and we'll measure the resistance by using the Ohm's law. So R is equals to V over I. So V is 6.4, I is 4.8 times 10 to the power of negative 3. We'll solve it by using the calculator, and we'll get the answer. So let me just solve it. So that is 6.4 divided by 4.8 times 10 to the power of negative 3. That would be equal to 1. Alright, so the resistance will be equal to 1333.3 ohms. So this will be the resistance of the LDR, 1333.3 ohms. Now let's move on to the next part. Okay, now in the next part it says explain why the potential difference across the LDR changes at the temperature in the house decreases. So as we know that well, I think it should be light, as the light in the house decreases. This should not be the temperature, this should be the light, because LDR is a light dependent resistor. So we will say as the light increases, the resistance of the LDR decreases. The resistance of LDR decreases. Hence, voltage or potential difference across LDR decreases. Because voltage is equals to IR. So as the resistance decreases, the voltage should decrease by Ohm's law. Okay, so this is not temperature, this is light, because LDR is a light dependent resistor, it's not a temperature dependent resistor, we have discussed before. Okay, now the next one, it says the circuit is left to run for 10 minutes. Calculate the charge that flows in 10 minutes when the current in the circuit is 4.8 milliampere. So as we have discussed the formula for the current, that current is I equals to charge per unit time, and we have to measure the charge, so we'll just rearrange it. So Q will become equals to IT, and Q is equal to I, that is 4.8 milliampere. So I'll write 4.8 times 10 to the power of negative 3, because it's milli, so we have to put a subscript of 10 to the power of negative 3 times, now the time is 10 minutes. So Remember that we have to put the time in seconds, because the standard unit of time is second and the standard unit of current is ampere. So whenever we use the formula, we have to put the values in their standard units. So the time is 10 times 60, because when we multiply 10 with 60, we'll get the time in seconds. So I'll just put this whole thing in the calculator and I'll get the total charge. So let me just put it in the calculator. So it's like 4.8 times 10 to the power of negative 3 times 10 times 60. So that would be equal to 2.88 coulomb. 2.88. So 2.88 coulomb is the answer for this question. Okay, now this will be 2.9 coulomb. We have to write this answer up to two significant figures, because these two values have been given in two significant figures. If you can see over here, it's 4.8. So 4 is the first significant figure, 8 is the second significant figure. So our answer should also be in two significant figures. So 2 is the first significant figure and 9 is the second significant figure. So the charge will be equal to 2.9 coulomb. So this is it for this whole topic of electricity with the exam question. Thank you.